Funding for this program is provided by Annenberg Learner.
How do you think a compound pendulum, which Joseph just said would be maybe 2 or more pendulums, how do you think it would act?
I can barely remember anything I did in my high school science classes, and hardly anything I did in I loved going on geology field trips in college to the North Shore and digging around in the rocks. And then the science methods class in Teachers College was ridiculous. It was a complete waste of time. I think I had to write a paper on water, and that's it.
What you're going to be doing today with your team is just the team, because there's 1 table for each team. That means there's 6 tables, 6 teams. This table is going to be suspended. It's going to be hung.
Suspended? Mine?
It doesn't, well, here you go. Here's a good vocabulary word. It doesn't mean the same thing as suspension in school. It's going to be hung between 2 desks.
I have a friend who works in a children's science museum, and when I told him that I was studying pendulums with my class, he said, "Oh, I have some great pendulum activities that I do with kids in the museum." So I asked him to drop me off directions on whatever it was I needed to build or how the activity worked, and he did, and I followed the directions and sort of launched into doing this activity.
You're going to put the string through the screw eyes, and you're going to hang it so that it's hanging down between the 2 desks. Let somebody start with it, and then I need another color.
I think that students are going to make discoveries through open-ended activities that I may not have even planned for them to make or expected them to make. And those type of discoveries or those thoughts you can only get if you give them the space to do it.
1, 2, 3, 4. You got to hang your table up between these two desks.
And then you need to, at the end, somehow get them to think about what they have gained from that experience through discussion or through journal entries.
The pen records the motion of the pendulum as the swing slowly comes to a halt. The pattern is determined by a number of variables, including length of string and strength and direction of the starting impulse.
I wanted some sort of an activity where they would be working with pendulums and be sort of discovering some things about pendulums on their own without me having to say, now measure your string and it must be exactly X length, now tie it in exactly this place. It also did give them a chance to see the pendulum as a movement that can result in some type of a design or pattern, whereas before their goal was simply to count the number of cycles.
Go ahead and get started. Tape your paper down on your wood and give your pendulum a swing and see what happens. Okay, give it a push.
Oh, that one looks better. Yes, the other one will work.
How could we make it different? How about if we put some weight on it?
Oh, shoot! Oh, shoot! Oh, yo! How'd you do that? Did you spin it? How'd you do it?
Did you just give it a push, or did you keep pushing it?
You just pushed it like no, we just pushed it, and then it moved by itself. Which way? Just teamwork. You have to work with your team. I know, but I can't
Look at how level their table is. Try making your table really level and see if that affects it.
I want them to know that science is, that it's discovery, that there's not a pat right and wrong way to do things. It certainly may affect the outcome, but scientists do maybe the same activity several times before they get the result that they want.
But I wonder if it's the way, how do you think it is? The way you hung it? Look at the way their table is between their, see how it's wider instead of
Why
long?
don't they do it for us when we do the drawing?
What if you hung this? Look at how there's this. What if you hung it so that it was wide here instead of long like that? Would that make a difference?
Yeah. I don't think so.
You don't think so? Why not?
Because it shouldn't make a difference if it's that way or that way. It
Yeah.
would still swing on top.
Yeah. But it's got. It's worth a try. I mean, I really don't know why some are working better than others. I don't know. So give it a try.
Ours isn't working, Miss Snowboy.
I know, Jenna. I'm sorry. I didn't realize that it would be so difficult.
Wow, nice.
Christina, you're never going to figure. You're going to give me one more chance. Okay? You know, if they were older and could be more focused, they could have actually recorded what it was that they were trying each time. But I think if that had been, I just decided not to have them work with their science journals today because I think that to stop and write down what they tried, you know, each time, so that each time they went back and tried to modify something else, they would know what they had done and what they still hadn't done. I don't think that they would have been very excited about having to record in their journals.
Giselle, why are you you're not supposed to be taking that black thing out. Giselle, give me it. Give me it, Giselle. Give it to me.
You know what? There are people. I know you're frustrated, but please don't yell at each other. They wanted that design. And instead of spending some more time thinking about what do I have to do to this whole structure that may result in that design, and there were kids who were taking the board and actually moving it themselves or they really wanted a result that looked like what they said was a pattern and everything else was a scribble. So I think that was a hindrance to them thinking, okay, is my table even? How are the strings attached? Are they close together? Is there an equidistance between the strings? If I knew, Jose, I would help everybody set theirs up. All I can say is that each of us had to try doing different things, tying it at different lengths, tying it evenly. I don't know how to make everybody's work exactly the way. You can take a look at the way they did it and see if you could set yours up the way they did.
We're quitting.
Yeah.
Yeah. Everything's broke.
No, it's like this. Gotcha. Recycle.
Let's throw out what you did. You've got stuff, even though it doesn't look exactly. Okay, but don't throw it out. Let's just see what we've got, okay? What was it about the design that Gloria and David made that people like so much?
It looked like not just scribbles. It looked like designs.
Okay, and you felt like the stuff that you were coming up with, you were calling it a scribble, not a design.
Yeah, they were scribbles.
Well, what is the difference between a scribble and a design?
Scribble has like all these ends that don't connect, and those have David stay connected. All the ends connected almost.
Okay, so it was continuous. What was going on in people's minds that suddenly made you say, I don't want to keep working with this challenge? If you could share that, that would be interesting to me. Billy?
Probably because you did it 1,000 times, it didn't work, and you kept on trying, then you gave up.
What are some of the things that people tried to do differently? If you could share some of the things that you tried to change about the way you were setting up your compound pendulum?
Shape. Instead of like we were doing it across, we did it like sideways. Instead of across, like across the desk like this, we just did it put it on like
So you changed
the
the
edge
position
of the desk.
of your wooden table.
We tried different heights of the board. First we tried like a little bit close, then we tried a higher, then we tried high, but each time we would get the same results.
Okay, so the height didn't seem to affect it.
And then we tried putting 2 markers in the thing, but that didn't work. So then we tried moving whatever that thing's called that you put the marker in. We tried moving that and then keeping the board still. And then we tried.
Frustrated with the outcome of this lesson, Sarah contacted the author of the compound pendulum activity.
After we had our lesson and it wasn't very successful, I called him and told him, and I said, you have to come into my class and do this activity a second time so that the kids see that it does work and help us figure out what was going wrong. So he did, and now we have a whole art gallery of compound pendulum art outside our classroom. Oh God, what have we got? We've got iodine, vinegar, Petri dishes for more iodine, alcohol. I mean, it involves lots of, little droppers, all the food, so that because we have to keep replenishing the food each time they do more testing. I did this about 45 minutes last night, and then I made the signs about how many to take of what. I made those at home. That was about, half an hour. This unit, we really have to be careful about not contaminating. So there are like spoons numbered for each. It's really materials intensive. I realize that today is going to sort of be a little rocky because they haven't used all of these materials before. But I will let them know that this is just, this is really an introduction to all the things they'll be using, and I'll be watching to see how carefully they're following their little check-off list for their activities.
Ryan, would you come up and get the food for your group? Let's see, Nicole, would you come up and get...
Sarah begins a 12-week unit on food chemistry. Activities in the kit involve students in testing samples of 12 different foods for the presence of starch, glucose, protein, and fat. In the introductory activity, students make observations about the various foods contained in the kit.
I've never taught this unit before, and the closest I would come to being able to say I had any background was a nutrition course that I took in college that I had to take for science requirement. So basically, I crammed my head full of facts from the text, took a test, and so I don't really have any background at all, other than just things that one reads in the newspaper. You're going to do an observation, a written observation with your eyes, an observation using your hand lens and write about it, an observation using your sense of touch, write about it, and an observation using your sense of smell. Don't check this off until you have done all of them, and then you'll know that you're ready to move on, okay? I thought that the worksheet that I made for them was helpful because it was really a checklist of what they needed to do. They needed to be reminded to look at it and check things off because they're quick sometimes to do things without reading directions. They just want somebody to tell them what they need to do.
It looks like with the flower or something.
Sarah met with Rick Duschel, a science educator from Vanderbilt University. They discussed how to provide focus for hands-on activities by enhancing the role data plays in science investigations.
Right. So let me show you what I do when I plan an activity like this, is that I would actually lay out the class data summary table as part of my plan for the lesson. These would represent the different groups of students. So, I want to get every group doing at least 3 measurements.
Right. Yeah, it's funny because I've done things like this with math.
apple and looks like candy.
We want them taking seriously the data recording and the data collection. And one mechanism for doing that is holding them responsible for a unique piece of data, and so that they're going to make a contribution.
Right.
So we now assign a responsibility of data collection to all of the groups. Now, so every group isn't doing the same thing anymore.
Billy, it looks weird, the egg white. I know.
I predict that we're going to see the students completing more of their work, that they will be actually recording and filling out the data sheets now where they weren't before. I think we're going to see follow-up discussions about lessons. Lessons aren't going to finish just with the completion of the activity, but there's now going to be things to talk about as a result of doing the activity.
Smells like a Beavis and Butthead sketch and sniff card.
I'm on peanuts.
I'm doing coconut.
Onions feel crunchy and firm.
By taking the information that they've recorded from their work this morning and then putting it up on a chart where everybody can see it and we can talk about it, it feels to them like there's a purpose to recording their observations or recording their test findings. And I found that it provides me with a way to wrap up a lesson rather than just saying, okay, we're done, clean up. I think what I'm going to do is remake the chart, actually, because I don't think that just looking at a sea of observations on flour will get us very far. I think it really needs to be divided up into observations using sense of touch, observations using hand lens, observation using sense of smell, and observation using your sight, just looking at without using the hand lens. Because then we can see, okay, well, what if we got here under sense of smell? This person thought it smelled like whatever, and this person thought it smelled this way, and we can really compare. But if it's just a sea of observations, I think it would be more difficult for us to have a discussion. I think kids might see, I don't know, there might be some pattern that they might find, or I just think it needs to be better organized for them to really be able to have a discussion about it.
Some people came in this morning and they noticed that the chart that you started writing on was not up here. The reason that I changed it was before you looked at it and you saw rice, and then there was this whole section here that was all mixed up with lots of different observations. But they weren't organized by all the observations that used your eyes, all the observations that used the hand lens, or your sense of touch or your sense of smell. And
with a better organized data summary table, Sarah's students are able to use their results to discuss what they have observed.
Jenna?
I thought the apple was going to be hard because, you know, when you bite into an apple, it's always hard, but then it was all dried up.
You feel better?
Because you have to bite it. You have to really take a bite.
When you do a hands-on activity, I would argue that there are three things that happen. The first thing that happens is you end up with data collection. Okay, well, some people are very satisfied with finishing the investigation right at that point. We've collected the data. You know, what did we learn? I think that the next step needs to be a data manipulation, and then after that needs to be data interpretation. Now that's more authentic. That's exactly what scientists would do.
We are going to test foods, the test foods that we've been using for glucose, and we're going to use test tape, which is a tape that's covered with an enzyme that tests for glucose. It's used by diabetics, and they've already used it to test liquids for glucose, so they're familiar with it. I'm losing my mind, Leah.
The kids really enjoy it.
Ooh, number one is turning. This is turning darker.
They like being able to mix things and sort of magical, these test results. You put a test tape in, you get a different color.
Granola bar is a yes. Coconut is a no.
Ew, it is turning. I guess Alvaro's right.
But ours isn't turning as dark as yours, Alvaro.
What? It needs more rice, you know.
Oh my God! Look at that is turning green.
Oh,
So we were right.
Rice is very light green.
By having a chart up on the blackboard for them to write their results down on, it means that unless you have something written on the sheet in front of you, it's going to be difficult to go up to the blackboard and write down your observations or your test results. So I find that it gets the work done, makes them stop and think about what they have to put down on the paper so that when they get to the blackboard, they have observations to put down. And then, as a class, in the end, we have something to look at and say, oh, well, this isn't this interesting. This particular food, everybody except this one group found a positive. Or, wow, this food, you know, there's a real mix of positives and negatives. I wonder what's going on here.
The only food that we all got the same test results for was the apple and the coconut. But the others, there's a real mixture, positives and negatives. Think about why we got such a variety of answers. Why some of the observations for the very same food were dark green, light green. Why do some people have negative, some people have positive? What was going on in here that we got such a variety of answers?
Some people, once they dropped the test tape inside, they saw the observation and they just wrote it down. But later it could have turned darker or it stayed the same color.
Okay. Other ideas about what happened, Leanne?
Yeah, when we first started and we would after we had put the 3 things in, when we were squishing the granola bar in, it was like just going in each pile, so we had to empty them out. They could have all mixed up.
Little pieces of granola bar were jumping into the other sections.
And then when we
What I find very useful in having this data summary sheet is it helps the kids evaluate the data itself. Right. And having these distribution of tasks to a data summary makes it possible to have these conversations.
Right, there's something to look at rather than just saying to them, so
what did you see?
Yeah.
What did you learn?
Right.
Exactly. There's all this intermediary kinds of things.
Right.
You put too much water in. Oh, you did it wrong.
Too much water? Do you think it was possible to put too much water in?
I don't know.
You don't know, but if that's an idea that you have. Maybe putting too much water in. Which foods do you think we should test over?
Coconut, because me and Max got light green.
Everybody got positive for coconut, but you think you'd like to test it again because it was just light green?
Yeah, I want dark.
But it may be that the food that you were testing only contained a very small amount of glucose.
That's so small.
The yellow is when there's no glucose. And then when it changes colors, it's smaller or larger percentages of glucose that the food contains, right? A dark green would be something that had lots of glucose. And the light green would be something that just had a little. Okay, so no matter how long you left it, in there, it may never turn dark green. Okay. Today, we've been asked by a marshmallow company to test their marshmallows and see what they contain. I told them what good scientists you were and how careful you were not to contaminate things when you did your testing. And I explained to them that you knew how to test for fats, proteins, glucose, and starch. If you look up on the board where we're going to be recording results, there are 2 groups that are going to be testing for fats, 2 groups testing for starch, 3 groups testing for protein, and 3 groups testing for glucose. I would like you, when you are assigned the nutrient that you're testing for, to do your test twice. How about you guys do, this way it'll be interesting, you can share your results. They're going to do protein and you guys are going to do fats. Okay? Would you please read carefully the sheet that you have in front of you? My perspective on teaching science has become more positive. I think that at the beginning of the year I was completely overwhelmed by materials management. How do you do these lessons within the space that my classroom provides, which is not very much space?
I didn't do it. His name was cool.
Even though it has green, I still like it.
Me too.
Oh, shoot. Oh, Miss Devil, it already turned brown.
Okay, so now look at the colors that are on the container.
Got 2 of them.
Which one does it match?
It got
2 or more %. Great.
What I tend to be thinking about lately is those students who may not be able to focus at other times during the day, but when it comes to a science lesson, they're really focused and really interested in doing the best job possible with the activity that they've been asked to do. And for me, that's really encouraging because I see that they are students who they're enjoying it. They're valuing the science lessons enough that they want to do well and not disrupt. I have had several students say, I'm really enjoying science this year.
Yeah, and then you're doing protein, so you need to put your little, yes, that's good. You need to have it be a little gooey and watery.
By adding a class results table to every lesson really gave them the message that it wasn't just a piece of paper to be filled out and then filed in their science folder, but they really had to collect some information from what they were doing to share with the class. And then sharing it with the class, we would get a sense of what everybody's findings were. Were they similar? Were they different? How different were they?
We were doing the same thing, and I got different results than she did. She got more brown, and I got like green, light green.
I think that students this year have come away with the knowledge that it's really important to record information while you're working on some type of scientific experiment.
You need to tell me what the prediction was that you wrote down, what your test results were, and what you observed, okay?
Me and Christina thought that starch would have.
And marshmallows.
The marshmallow contains starch.
Okay.
And we were right.
And you were right. And how were you right? What were you using to do your test?
Iodine.
Iodine.
And what'd you find? What did it look like? What were your observations?
Black.
You want to show people? This is test 1 and 2?
This is test 1 and that's test 2.
Okay. Each group was testing for something different. So if you wanted to know whether it had starch, you had to listen to the kids who tested for starch. You didn't get to say, oh, I already did that, I know what the answer is.
What was the procedure that you followed for testing, and what did you find?
We smushed up the marshmallow and put it in water so it was soaked and it got smushy, and then we put the tape on it, and then the glucose tape. Then we put it in alcohol and vinegar. Then took it out at 5 minutes, and it didn't have any protein.
How did you know it didn't have any protein?
Because it was plain white.
So okay, so you knew there was protein if there was no blue color to it at all.
I think next year I would put more emphasis on observation so that kids really think more about using descriptive words to describe what they've observed rather than just it turned, it changed, you know, that kind of stuff.
The first test that we did, I got a little bit of brown and blue, and she got blue. And then the second test we did, we both got brown.
And did you predict that it would have glucose?
Yeah.
You did. First of all, if you were to speak to a representative from the Kraft Marshmallow Company, what would you tell them about their marshmallows? What do you think they should tell people about whether they're healthy to eat or not, what they contain?
We could have had kids read a chapter on fats, a chapter on proteins, glucose, starch, and maybe 2 kids would have walked out of here remembering anything that they had really read.
First, tell me what you think you would tell them based on the nutritional value. Nicole, what would you tell them?
It has a lot of starch.
Okay, and what is starch good for? Do you remember?
Energy.
Okay.
You don't have
Sugar. I would tell her it's good, but try to add a little fat into it because fat's good for you. It is.
You do need some fat, that's true. You do need some fat. And our diets, usually our diets have more fat.
Half of a gram.
It's funny because all the things that I've done around science education and math education since I started teaching were really because those were 2 areas that I didn't feel comfortable teaching. And now it looks like those are like my passions. If you look at my resume, you know, it's like this math, science. When really I'm just a social studies and literature person at heart.
Do you think you learned anything about marshmallows that you didn't know before?
Yes.
Can you give me an example, Gloria?
I didn't know that marshmallow has starch.
Okay. Anybody else? Jenna, something that you didn't know about marshmallows before today?
That it's good for you little because it has carbohydrates.
Okay, so if you needed some, okay. If you were about to run the marathon, you might eat some marshmallows.
Funding for this program is provided by Annenberg Learner. For information about this and other Annenberg Learner programs, call 1-800-LEARNER and visit us at www.learner.com.